let's do the next one on this list. You're given an array of points representing integer coordinates of some points on a 2D plane where points of x, y, the cost of connecting the points is the Manhattan distance. So take the x's, take the y's, take their absolute difference, which is the minimum cost to connect all points. All points are connected if there's exactly one simple path between 2 points. Oh, okay. Okay. Interesting point. Okay, this is actually a really interesting one. Okay. So we have 0, 0, 0, and so the explanation, we can connect the points as shown in the graph. Ooh, okay. We can connect the points as shown above to get the minimum cost of 20. Notice that there's a unique path between every pair of 2 points. Anyway, so this is 4, 3, 9, 4. Okay, I have an idea. So we can have the table-based graph where each table or a list of all the points. So I would have to assign them somehow. And basically that represents but the problem is I don't know how to. Okay, instead of list of points, I'm gonna have a map of points where so the point is the tuple coordinate, give me the value which is cost. Okay, so cost to get to shit, hold on. Damn, bro. Okay, I see the vision now. So basically, yeah, that's easy. Okay, so the cost is basically the closest point, the nearest point that I can get. So I can try to calculate these two, this two, this two, and like basically calculate all of these. And it's basically going to so cost of the smallest node, cost, no, the distance, the smallest distance to the nearest point, to any neighboring point. Okay, so that's what it is. So that's what it is. So I'm gonna call this points, right? So points, the smallest distance to any neighboring point, correct? So I can pick this. Okay, yeah. Okay, so yeah. Cost. Yeah. So yeah, that's all I need, right? And then basically I'll go through all the thing. So let's make this. So let's create the table for every point. Let's do x y in for every x y in points. Table of x. We'll do x y is equal to float of infinity. So print table. So that's basically it. Right? Yeah. All that's all we need. Just basic tuple of the thing. And then I need to calculate. So for yeah, and then for every source in table. Actually, yeah, for every source in table. Hold on, let me print table source. Okay, perfect. For every source, let's call this x y in table. Calculate the distance. So, wait, can I? Okay, so basically, I need to. Is xy unique? Distinct. Okay, perfect. Then, for every point, let's call this x1, x2, or y2, or not y1. Let's call this x2, x2, y2 in points, right? If x1 does not equal x2 and x1, or y1 does not equal y2, right? Then table of x1, x2 is equal to the min of table of that right? Or y, so what was the fucking formula? Distance is equal to, let's call this x1 minus x2 abs minus or plus abs of I. Yeah, it's fine. Y1 minus y2, and pick the smallest distance, and we'll try with every single point, and the points we will skip is itself. And yes, then print table. Yeah, let me see if this doesn't break. Okay, so we have the numbers what we want. So we need 4, 3, 9. Oh no, we have 2. Oh, yep, 4, 4. 9, 4, 4. Yeah, never mind. This doesn't work. Am I missing something here? Let me do dot keys. Does that make a difference? 4494. Not good. This is not what we're looking for. 4493. Okay. So basically let me just make sure I'm print. Oh wait, yeah, that's fine. X1, X2. Oh, Y2. Wait, X1, wait, is that the formula, right? X1 minus X2 plus Y1 minus Y2. Yes. Plusing them, right, yeah. Okay. And let's see this here. Print X2, Y2. Brother. X2, X1, Y1, X1, Y1, yeah. Alright, let me see this real quick. So 0, 0, and 0, 0. 0, so let's call this source. Oh man. Brother. Are we only iterating through? Why are we only iterating through? I feel like what's happening here? We're not iterating through any, wait. Brother. Why are we iterating through nothing? 0022 310 5207. Yeah. Huh? Oh shit, I shouldn't be doing this actually. I'm altering this too, so it's not really good. Fuck. Actually, I have an idea. Instead, we just do points. Hold on, let me try this again. Let me rethink the logic. So, so let's do for I in range, range of length of points. For j in range. No, because I need to explore all the other neighbors except itself. That's why. Go back to this real quick. I need like a fixed. So table dot values or items. That's just key value though. I don't want key value. I just want keys. So yeah, it's this. Wait, why am I? Okay, yeah, I'm like, cause I'm altering the table as I How about this? Okay, how about I create the? How about I just screw this? I'll do this. Table current value. Current distance is table dot get x1 x2. All right, y1, right? Well, that's just obvious. Else give me float inf. and we'll do per distance here. So yeah, return the sum of the table dot values. Okay, let's see what I'm really doing here. So I'm going through every point. I'm going through every points again, making sure they're not the same self. So I would skip that. I'll do 0, 0 in this, 0, 0 and 3, 10. Calculate, 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 and just, yeah, calculate this. It's pretty simple. GG's, boys. I don't know why this is wrong. Print table. 4, 4, 9, 4, 4. Okay, so that's exactly what I got. Okay. I need to know why. Let's see. We can connect the points as shown to get the minimum cost of 20. Notice there's a unique path between every pair of points. So, which one? This is 2, 2. So 2, 2 is getting 4 when it should actually be 3 because this is closer. But why am I not getting that actually? IJ, IJ. Y1, Y. Yep. Who would get me the distance of cost 3? Would be 2, 2, 5, right? So, yeah, so why don't I do that? Let's see, is there like the math problem? So 2 minus 5, 2 minus 5 plus, is it minus, right? Minus, right? Yeah, plus 2 minus 2. So yeah, it should be, oh shit, 0. Wait, what? So this is 2 minus 5, 2 minus 2 is 0. So 3, oh yeah. So 3 plus, yeah, why does that? Okay, let me print distance. Oh, I know why. Let's just do this. X1, Y1. X2, Y2. That's why. I just because you can have the same X, Y's, it's just, they can't be the exact same. That's what I was trying to do. No, brother. Distance. Oh, that's the wrong value. Table. Bro, why is this happening, bro? Okay. 4, 3, 9, 3, 4. 4, 3, 9. 2 4s, 1, 3, and 9. 2 4s. Oh my god, we got another 3. That's what the fuck? Wait, there's how many points? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So 0, 0 should be 4. 2, 2 should be 3. 3, 10 should be 9. 5, 2 should be 3. Okay, yeah. And 7, 0, 4. Yeah. What? Am I stupid? 20? Wait, what is the cost? 4 plus 4 plus, isn't this the sum, right? Wait, what? 4 plus, wait, 4 plus 9 plus, 4 plus 3 plus 9 plus, 4 plus 3 plus 9 plus 3, 4 plus 3 plus, 4 plus 3 plus 9 plus 3 plus 4. That's what I have here too, right? Yeah. Oh shit. Wait, it's not 20? What is the sum then? Return the minimum cost to make all connected points. All if there's exactly the same one simple path. Uh-oh. Wait, I must be missing something. What am I adding here? Wait, what? Oh my god. Wait, what is the cost of 20? 3 plus, that's 7, 11. Oh shit. Wait, whoa. 4 plus 4 plus 4. Oh, there's an extra 3. Oh, they share the same. Oh my god, I see the issue now. I have an extra 3, that's why. Because the cost from 2-2 and 5-2 is like the same, I guess. Okay. Like, I don't want to duplicate it. Yeah, that makes sense. Okay. Damn, how do I make sure that that's not good? Yeah. How do I do that? Oh, man. So 2-2 and 5-2 are basically the same. GG's, boys. I don't know. Okay, basically, if they're in the same... Yeah. So if they span out everywhere... Okay, I guess if they're the same level... Okay. I basically have some repeats, that's why. Okay, I think I got this whole algorithm wrong. I need to basically build out the graph. Okay, let's do that. Let's try to do that, I guess. Fuck me, man. It sucks. Let's do like default. So we'll have like point and cost, I guess. And I guess the start is just whatever points is, and then we can use like a heap, I guess, to like prioritize the like where I pick, you know. I guess we could start 0. Is 0 always gonna be in the thing? Not necessarily, but it doesn't matter. I think I can just pick like 1 point and then just make a graph from that. Okay, so I guess source. I guess we'll have a queue. And basically just pick the smallest smallest thing, you know. And yeah. So the cost to be in points of, so I guess, yeah, points of 0 is just nothing, right? To be at the point, like the first point is nothing, right? But to go from points to here, that costs 4, right? So yeah, so while q cur dot equals q dot pop left, actually heap, I actually want to heap pop q, and yeah, well, let's peel this out. Let's do xy cur of 0, and we'll have and then just add basically add, okay, so now I can add to the queue, or the queue. So for every I in range of length, actually we'll do a 4x x2 y2 in points, let's call this x1, y2. Okay, so yep, if x1 y2 does not equal x2 y2. Okay, as long as it's not the same node, basically just calculate all their distances and then put it to the queue. Q dot heap, or heap push the queue and the distance. So we'll do we'll do points. Mother God, bro, this is so AIDS. Points of 0. Wait, so what am I doing? Who do I want to put? Basically the, maybe I can calculate the, it's gotta be a better way. Actually, let's do, instead of checking like this, we could just add a scene. Have like a set, and we like, while length of scene is less than is like less than or equal to n. Yeah. And then we can, like, as we build, we can just do like res here. Yeah, we'll do this and return res. Okay, so I have to, okay. I actually should do point index. Let's do the index and then the cost. So point index, yeah, so I don't have to like hard code it. and PQ. Let's call it PQ. And basically, if cur dot cur equals this, heap pop PQ, and if cur in scene, continue. Otherwise, we can cost is equal. So we'll do res cost, which is just basically cur of 1, like that. Cost is here, that's that, and then we can get the x1, x2 equals cost, not cost, cur of 0, right? Not x2, you idiot. It's fucking y2. Oh, not y2, y1. Then go through for every I in range. Let's put n here. Let's do n is equal to length of points. And just use that because we're using that a lot. Right? Let's call this j actually. Or let me unpack this. This is I and then cost. And then we put I. I don't need this. I just do that and then put I here. Not even cur, bro. I just need to do points. So yeah. So then iterate through all the ones. If j in scene, hold on. I'm gonna say if I in scene. I dot, so let's do scene dot I. If j in scene, okay, I guess not in scene, then we will add it to the heap. Well, actually, let's calculate the distance, or let's do x2, y2 is equal to j, or actually points of j. And then distance. We'll do ABS of x1, x2 minus x2 plus ABS of y1 minus y2. Then heap push into the PQ and this, and then we'll put the index and distance. Basically, so we'll do this, right? So we'll detect this guy here. I think this is 2, that's the next one. Yep, so we take that, take the distance, which will be 4. And if I want to get to 4, this point, and this is a problem. I don't want it to calculate other stuff though. Yeah, okay. Yeah, this makes sense. So I want to calculate all the ones here, and that makes sense to me. Yes, this should work. So we're like calculating. Wait, I don't want to do this. We're calculating like all the points. Okay, I don't need this actually. We're calculating all the points from here. So like here, I calculate all the distances and put them in. So I put them in the priority queue, and then I mark this as done, and I pop basically the smallest distance. Oh shit, hold on, that makes more sense. Okay, that's why I need to put distance first. Yeah, I have to put distance. Yeah, that makes more sense here. Let's flop these cost and an I here. I think this should work. Yeah. Awesome. All right, see you guys tomorrow.